Hey guys, what's up? Eddie Aho here with KissAnalog.com. So today we're going to start a series. I kind of started it before with another amplifier, the ICE amplifier, but I didn't really get to the final thing which I want this video to be. I want to just go fairly quickly through all the test measurements and show you what they are. I don't want to drag this video out too long, so I'm going to kind of go fast on this one. I did two previous videos where I set up this thing, I tested the amplifier, tested the power supply, made sure everything worked, put them together, and then I did some other testing to get ready to get the signal levels for the QuantAsylum that's sitting back behind me. And now we're ready to use a QuantAsylum, and we're going to run through a bunch of tests. I think there's like 7 tests that we're going to do, okay? Now, the whole idea of this is to really exercise amplifiers and even preamps, but amplifiers in general, preamp, power amps in general, to give an idea what they, how they perform and what they might sound like. So maybe if you get one of these amps, or you've heard a particular amplifier sounds really good or warm or whatever, we can describe that. We can say, yeah, that's because it tested this way during this test. And so, yeah, you should expect that. I mean, that's the thing that we should have. It's like the audio industry has kept us from that kind of information. They want to muddy the waters, and, at least that's my feeling. Or they're just not, they just don't know enough about their products to be able to talk intelligently. I don't know which one it is, but it seems like it's got to be one of the two or something in between, because it is really vague, and it's crazy that, for instance, people will spend a lot of money on a power cable, $200, $2,000 on a power cable, but they won't ask an amplifier manufacturer to give them an amplifier that has a regulated power supply. And the audio people have been, audiophiles or whatever, audio community's been educated to believe that that's a good thing. And it's not. I can tell you, that's just not a good thing. Should have regulated power supply rails. All there is to it. So if your power supply sucks, then okay, then you didn't do a good job regulating it. But if it's good power supply, then it should be great, and you should be able to hear the difference of that versus somebody saying you can hear the difference of a power cord. So, okay, enough with that tangent. We got to make these videos short so that we can just get to the specs. We're going to make basically a spec sheet. We're going to have 7 different tests. The first one is going to be the Borbede plot. So basically, it's the frequency response of the amplifier. Let's say, for instance, we have an amplifier that has a gain of 20, okay? Then, sorry guys, got allergies really bad today. I've been out in the yard this weekend, and I think they just kicked my butt. But anyways, so frequency response. If you have an amplifier that has a gain of 20, then if you put 1 volt in, you get 20 volts out. 20 volts out, let's say it's 4 ohm load. Well, then that's 20 squared, V squared divided by R power, right? So 20 squared divided by, say, 4 ohms should be 100 watts. So we should have 100 watts out. Well, now if you take that 1 volt and dial back halfway, say half a volt, well, then the output should go back halfway. Should be linear. They should work together that way, okay? So when we do the Borbede plot, the frequency response, it's the output voltage, say that 20 volts divided by the 1 volt, should be a gain of 20, and it'll be in decibels. So we should see that, right? Now, typically that's only done at 1 watt. We're going to start at 1 watt. We're going to go up to, I think we're going to go up to 110 watts on this guy, okay? And I've got another one on the boards right here. So we're going to go up to 110 watts. This guy's labeled as a 300 watt plus 300 watt. Yeah. I mean, we all know that's not true. But it can put out 110 watts. And we're going to talk about that a little bit more. It'll thermally shut down. If you put a really small fan on the heatsink, it'll continue to run. But in a video following this, I'm going to do a few little modifications, easy, low-cost modifications to try to improve on this. I'm going to see if I can do that. But anyway, back to the frequency response. If you put half a volt in and it goes up to 10 volts, 10 divided by half is still gain of 20. So my point is when we do a Borbede plot at 1 watt and it's this curve, let's say it's flat between 20 hertz, 20 kilohertz, and then we do it again at 10 watts, which we're going to do, or 10 or 11 watts, and then 110 watts. At each one of those power levels, they should ride right on top of each other. The gain should never change dependent on your input voltage or your output voltage. It's the same gain, at least it should be. So we want to verify that. So that's going to be one of our tests. So yeah, we're not going to do just a basic 1 watt Borbede plot. Okay, that's where it's typically done. And then THD, it's typically done at 1 watt, 1 kilohertz. So we're going to do that, but we're also going to do, you know, other powers, like say, I forget how many we're going to do. We're going to, on all these tests, I think we're going to do at least 3 of them. 1 watt, 11 watts, and 110 watts. Okay, we're going to do at least those 3. Some of them we'll do up to 10. But so we'll do that THD at 1 kilohertz and do those. But then we'll also do a test where we do those same power levels, but we'll change the frequency and we'll go all the way across from 20 hertz to 20K to see if that THD, let's say we had 0.1%, 0.01 at 1K. Does that stay the same at 10 watts or 11 watts or 110 watts? Or does it stay the same at 100 hertz or, you know, 15 kilohertz or 20 kilohertz? So we want to, these tests are going to show us all that stuff. That's why there's 7 of them. And that's why I'm going to bring you over to the bench, show you the setup, and take you through these tests. We're going to go pretty quick, okay? So let's go ahead and do that. And the first thing I'm going to show before the test actually, I'm going to show you the test setup, okay? I'm going to do that right now, as a matter of fact. So I've only got the QuantAsylum hooked up right now. So no, the mix sig, I'm going to go ahead and show it to you. So we got our 4 ohm 200 watt resistors, okay, on the right channel and the left channel. So we're powering both channels. The differential input coming into the input, they're shorted together. So both channels are powered up. One channel we're going to be reading, okay, and we have a differential reading on the output. On both the output and over here on the input, the shields are tied together, okay? They're also twisted up to, you know, from the coax to the top, they're shielded. All right, and then the power is also twisted and it comes over and connects down here. The only thing that's connected on the mix sig is this current probe, so it's galvanically disconnected. And AC power's here, and it runs down the back side over that way. I've experimented with the AC power. I don't have the chassis ground tied. I've experimented with that. Doesn't seem to change the measurements at all, as far as I can tell. So I'm just trying to make this as simple as possible. Okay, over here is a QuantAsylum. So the output of the QuantAsylum, differential pairs of plus and minus, are what we use in the center conductor on each one of these going to drive the input. The shields, the outer conductor, is just tied together. They're tied together up here, but then they're tied together back at the where you saw before. And here is the input signal coming from the amplifier. Same thing. There's a plus and minus, same setup, okay? My picoscope down there. And by the way, these screwdrivers are awesome with the plastic sheaths. So I've been using that. And now the QuantAsylum, I have it's the QA401 24-bit. So there we go. Okay, and then I have my MacBook Pro. And by the way, this is an older model. I forget how long I've had it, say 4 years, something like that, maybe longer. But it's my MacBook Pro. And I think it's only an i5, so it's not super powerful. Someone asked, you know, do I need a powerful computer? And, well, that's what I have. And everything works great. So, all right. So, yeah, there's the mix sig. He'll be looking at the current. And so we're going to go ahead. But now what I want to do is I'm going to go ahead and record the screen so you can see a really good picture. But what I want to show is, look how quiet this is. This guy's running, okay? He's not injecting a signal because there's nothing to inject a signal right now. The amplifier's not powered up. But I want to show you that little 60 hertz spike. Now, it's about 105 dB roughly, I'm thinking. Yeah, here we go. Right up here, 105 dB and 6.8 microvolts. So that is just noise that's picked up everywhere. It's really hard to avoid getting just totally clean power, which I will attempt to do that as we go on. I have some really nice isolation transformers. We'll see if that helps, but I have a feeling it's not going to. But that is such a low signal, so we don't want to worry about that. But I just want to show that everything starts off really flat. Now, even if I turn on the generator, there's the signal. And look, the 60 hertz, okay, it came up slightly, but it's going to drop. But yeah, it's about the same probably. It's pretty close. So, and there's our signal I got coming out. This is the one that I think minus 17 dB. So this one is the one that I think will give us the 10 or 11 watts. I think it's 11 watts, just shy. But, all right, so I think we're ready to go. All right, guys, so I just wanted to show you the noise floor. You know, I don't have any ground loops or anything like that. It's very quiet before I start powering things up, all right? So once I power this thing up, then there's just two wires coming in here. There's no chassis wire connections, no earth ground, safety ground connections. It's all isolated from that, essentially. And all right, so let's go ahead and, as a matter of fact, I'm going to record this screen so you can see a little bit closer, and then I'm going to start showing you test results, okay? All right, guys, so this is the same screen that I showed you on my camera. I'm just showing you a screen capture here so that you can see it very clearly. If you want to capture your own screen, pause it, whatever. So you can see the amplitude at 60 hertz, right? Now, I'm going to come over here and turn on the generator, and I don't think that changes. Also, the noise floor, it's almost 120 dB. This is just crazy good. Okay, let me turn on the generator. Okay, there we go. All right, so yeah, it kind of jumps up, but then it settles back to the same spot. And so things look pretty much the same, right? This noise floor, except for this spike, right? Okay, so I just want to point that out. So I'm going to put up my blast shield. You guys seen it in other videos just to keep shrapnel and stuff from hitting me in the face. And I'm going to put on my safety glasses. Okay, so we're going to go ahead and turn on the power. And we're going to start the first test, okay? All right, so there's the output. Now the reason so I should explain. We're looking at the output. That signal we saw was just what was creeping through the device, okay? Because this thing is so bloody sensitive, we actually saw it. But now you can see it's way up here, okay? So this is 16.4 dB or 6.6 volts RMS. It's roughly 11 watts in the 4 ohms. Now, THD, once you get up around, I'll just tell you right now, once you get up around, 10 watts, 11 watts, you're looking at about 0.34%. Okay? Now, over here is THD plus noise. At this point, we're not adding a lot with all the noise. So, see these spikes here, this one here, this one, all these harmonics, these are the harmonics, right? Equal multiplications of this 1 kilohertz signal. So that's what that is. Now this stuff over here, could be coming back from the switching power supply for the Class D. The modulation from, well, I call it switching power supply because I look at Class D amps as basically switching power supplies, but this is the Class D switching, I believe, okay? The harmonics, subharmonics from that. Because, well, actually, let me see, what frequency are we down here? Well, this is 10 kilohertz, right? See it down here? 20, 30, 40, 50. So this is 50. I think this is a subharmonic of the switching power supply. I think it switches at 450. So that's probably actually, 45 kilohertz. And then this is probably another subharmonic. And all these little side bands, that's probably the 1 kilohertz side bands on these subharmonics. So I think that's what all that is. So that could be, massing some of this distortion through here is probably the Class D switching, like subharmonics. These are the harmonics of the 1 kilohertz, okay? Now this stuff here is like 60 hertz, 120. I mean, it's crazy. So this is the stuff from the switching power supply that's feeding our input. And the 60 hertz jumped up to minus 50. The rest of these are really low. Even minus 50 is low as far as signal to noise. This is 16 dB up, right? And this is 50 dB down. So that's like, 66 decibels between there. More than that, actually. So, yeah, that's quite the difference. Anyway, just wanted to point out what we're looking at here before I even start running the test. Now, I'm not going to make you watch all these tests as I run them. I'm going to just jump to the results. But I just wanted to show you this first one because I wanted to show you how it's interesting. Here, let me turn off the thing because I got to do that start a test. And we're going to come to frequency response. And we're going to go from 1 watt. And we're going to go in 10 dB. Yeah, we're going to take a bunch of readings, okay? So we're going to take 10 readings between that and 110 watts, okay? And we're going to go, well, it looks like we're going to go from 10 hertz to 80 kilohertz. Oh, and the reason I want to go to high frequency is because I saw this guy have an interesting roll-off at 20K. So, just as a preview. And this series name, TPA3255, 300 watt, just so I know which board we're talking about. Alright, so I'm going to go ahead and start this test because I just want to talk you through this. I'm going to move this out of our way. Now, what I want to point out is this signal and its harmonics, you end up kind of seeing them roll together across the screen. And the power supply noise, like this guy and the harmonics from this guy, you won't see them changing, right? See, so here's the guy here. You see this little harmonic? They're really low down here. At this level, we only have 0.027 or 0.01, so it's very low distortion. But what I mean is you kind of see them, a little group of them moving together, right? And as we go higher frequency, I think these increase just a little bit. We're at 0.02% right now. THD plus noise is 0.08. So yeah, I just wanted to point out how you can see the noise that's basically like ambient noise. It's just here. It's whether it's from the switching power supply feeding us or the Class D, this stuff is just there. And then the harmonics from this guy are kind of riding along with it as it goes through. You see right here, here's one right here, there's one. You can kind of see them kind of go together. And then, so up here you can see THD+N is higher than the THD, just our harmonics. When you look at just these harmonics, it's this value, but you include this other noise and it increases a little bit. Now again, we can see all this stuff just because of the 24 bits of this machine and the great resolution. Like this stuff down here below these numbers, I mean, this stuff is all so low that I don't think we can hear any of this stuff. Alright, so I am going to not talk, and I'm going to speed through this just so you can kind of see. When I speed through it, it's more obvious watching the frequency. It's our harmonics as a group kind of move through this crowd of noise, okay? So I'll be quiet and we'll speed through this. Alright, so we're out of the audio band, and I just wanted to show you that. See this spike right over here on the far side? That's a subharmonic from the power spike. It's always there. And then this guy over here on the far left, 60 hertz, and all his buddies right along here. So just wanted to point that out. It's kind of interesting when you speed through it and you can kind of see it's a little more obvious. All right, and here is our graph from that measurement. Let me just expand that. Okay, it looks really nasty. All this stuff here, all this crazy stuff on the left, it's just, I don't know what it is. I think it's a timing issue with the analyzer and a Class D amp. I think that's what it is. Not sure, but I've seen this kind of stuff in the past, and I think that's what it comes from. So when the signal gets put into the Class D amp, there's a time delay before the Class D responds. And meanwhile, this guy's trying to take a measurement, and it's like, whoa, 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 what's going on? So now the thing is, though, is all the music, it's like all the kids on the bus are all on the same bus. They're all delayed a little bit, but they all arrive at the destination together and phase and sequence with each other. So your ear can never hear it, but an analyzer looking at sending an input and looking for an output, I think that's my best guess what's happening here. So let me know if you guys know, and I'll try to ask QuantAsylum folks if they can tell me. So all this stuff's kind of crazy. This blue one right here, which turns out to be the highest power one, minus 7 dB, that's the 110 watts. It kind of leveled off, and it stayed kind of level and dropped off. Now, at this point, around a few hundred hertz, they all kind of finally settle in, and then they're okay. So, yeah. I don't know if it's because the analyzer at low frequencies expecting something to happen, and there's too much time at low frequencies, and high frequencies things are happening quicker and it catches it. I don't know. But all these phases, these are all the phases I'm pointing at. They're all, if you look up above, you know what? It puts the phase and the frequency on top of each other. Let me shrink that back down. Yeah, I like it this way. I wish I could control this window more. Yeah, so over here we have the frequency response on the left and phase on the right. All right, so 0 degrees right here in the middle of the screen on the right side, and we're going up 50 and down to minus 50. And these phases, all this jazz, and then right here, this is all the phases. So they're pretty close to 0, it looks like. And then around 1 kilohertz, they start to separate a little bit. And 20 kilohertz around 45 degrees. So that's not bad at all. Okay. These lines here, the black, what looks like a black line, look how it's these three powers, the 1 watt, the 11 watt, and the 110 watt, all right on top. So that's that gain I was talking about. So from 10, and now look, this is from 37 to 31 dB, right? This is very flat. And I mean, especially if we look at 20 hertz, 20 hertz is right here. From 20 hertz all the way out to here, it's super flat. And then it starts to drop a little bit. This is 2 kilohertz, 3, and it's still really close. But right around 10 kilohertz is when it starts to separate. Sometimes on filters, you can have a gain on a filter before it actually rolls off, and that's what's happening here. So the red one comes up here, the green one actually drops down lower, but then it goes up higher. And the black one drops down lower and then, drops off here. So anyway, 20 kilohertz is right here in the middle of all this, where they all start to separate. And even there, if we look over here from 33, it's only separating by about 1 dB. So in a lot of people's books, that's okay. Half a dB, 1 dB, it's what people want. I like to see something even closer these days, especially with Class Ds. I've seen some really cool filters at Class D where they go out and then they just drop off. So this thing here, I don't like. I don't like how there's a gain here. That should not be, okay? So right there, we can kind of tell what this amp's going to do. At high frequencies, it's not going to be as bright because, it's dropping slightly. But then you can't hear this anyway. But this isn't good. The amplifier's not going to like that either, because if you're listening to 110 watts here, that's going to be higher power right there. So if you're close to thermally shutting off, that, if you had something that come through your amplifier, hopefully you don't. Hopefully you're not getting things at like 40 kilohertz. But if you did, that could shut down your amp. So yeah, that's just weird. If you're just getting music come through your amplifier out to 20 kilohertz and it's rolling off, then it should never see that stuff. All right, so that's that test. Let's move on to the next test. All right, guys, so the next test, the test we just did was frequency. It's called amplitude. It's under the amplitude test. Frequency response. So that's that's a good name for that test. The next one is gain and distortion versus, so we're going to look at two things, gain and distortion versus amplitude. So I think we're going to go through our different power levels and look at both gain and distortion. So let's run that one. Same thing, minus 27.7. And we're going to take a bunch of readings again. Let's go ahead and run that. Okay, I'll move this out of the way again. I'm not going to make you sit through. Some of these tests are super fast, but the ones that aren't, yeah, see, that was a super fast one. So, all right, guys, so this is the results of that test. And the gain is over here on the left. So again, oh, and by the way, at the top of the screen, it says gain, and left, L means left channel. So we're just looking at left channel, but see the black one? So look how flat it is. Now this is showing in respect to input level. So if we put in high power from 1 watt, 10 watts to 110 watts, it did drop a little bit in gain. So can anybody hear that? So leave me your comments. Tell me what you think. So up here, the next thing over is THD. And then the one after that is second harmonic and then third harmonic. So THD, this blue line here, we look over the right side, it starts right around, these grids don't match up with the right side because they match up with the left side. So it's about, minus 72, right? So it's about minus 72 maybe, and then it goes up. So the point is as amplitude goes up from 1 watt to 10 watts, it went up to about minus 46 or something like that, minus 48 even. So that's still pretty darn low. And then it went up to about minus 44, 110 watts. So it is going up with power level, okay? So that's what this graph's showing. It's pretty interesting, right? Okay, let's move on to the next test. Okay, guys, next test. We did that one. We did the gain and distortion. Now let's do THD versus frequency. Okay, that'll be interesting. All right, so same thing, minus 27, minus 7, but we're incrementing 10. That's why we're seeing 3 different readings. Okay, let's go ahead and run that. I'll move this guy out of the way. All right, guys, just jump to the test. Trying to keep this video shorter, right? So, all right, so up to the top we have our power levels, the 1, the 11, and the 110 watt. So the red one's 110. So you can see over on the right, THD+N this time. So it's plus N. So when you compare these pictures, remember which ones are THD and which ones are including noise. So now this time we're starting at 20 hertz and it goes up with frequency. So that's one thing to know. The other thing to know is the red one's the highest one. So it goes up with power too. So THD plus noise is increasing with frequency and power. So another interesting note. We're going to have a little bit more noise at higher frequencies, and we're going to have more noise at higher power levels. Also, the shape of it's kind of interesting. The red one's just a ramp, but the other two, right around 200 hertz, takes kind of a ramp up. So it goes from, you know, like down here 0.02, 0.03 kind of thing, up to just below 0.1. So again, you know, some studies say under 0.5, very few people can hear. So 0.5 would be up around here. So this 0.5, so you can hear it. So, you know, there's people that can start hearing this kind of noise, especially in these frequencies. The people that can hear 0.5 and above are usually hearing these frequency bands right here. So at this low power, 1 watt, you're probably not going to hear anything. Now this spike over here on the far right, again, it's just an anomaly. Whenever you get one weird point, it has to draw a graph up to that point back down. So I think that's just an anomaly. But the rest of this, look, see, this, so, you know, pyramid over here, another anomaly, I believe. And maybe these two. It's just like lack resolution or just a bad point. So if we were taking infinite number of points through here, even if we had one bad reading, it wouldn't create this, you know, pyramid looking thing. You notice the base of it's about the same width as the base of this pyramid. So, and these, the width of them. So that's another tip to me that it's just an anomaly. It's not real. But this is real. This looks real. How it ramps up this way. And then also how it ramps up here at this frequency. For some reason at 2, 3, 4, 5, 6, 7 kilohertz, there's a peak. And then it drops off again, which is interesting. So 7 to just above 10 kilohertz is pretty low again. So that's curious, right? Like, what the heck's going on there? This thing right here and this thing right here, I think are, even, you know, whether you can hear them or not, something in the amplifier is kind of, so we got to look at other tests to see if these frequencies, if we can see anything happening, because maybe that's adds some color to the amplifier. So, all right, so next test. All right, guys, so that was THD versus frequency. So let's do THD versus input to output. Okay, sounds interesting. Same thing, mine's 27 to 7, 10 dBs. Okay, let's do this. I haven't named a bunch of these, you can tell. Move this guy out of the way. Wow, that was a fast one. Alright, I kind of blew it up, kind of pulled it up, added title and stuff. So, alright, so now THD+N over here on the right again. Okay, and bottom screen's 0.1 and 1. So this stuff's a little bit higher. Now this is the 1 watt, 10 or 11 watt, and 110 watt. Okay, so THD plus noise over here on the left. So this is just another picture. This is just showing the 3 different amp. Now this is done at 1 kilohertz. So I added 1 kilohertz. So if you look at 1 kilohertz from those other plots, if you look at those 3 different lines we saw, that's what this guy is showing. So instead of looking at each 3 lines to see how it's increasing with your power, this is that graph. So basically the same information shown in a different way. Okay, let's go to the next test. Alright, so where are we? THD input versus out. We have one more THD versus... Oh, this is if I had the QA480. Not sure what I'd see different. These are for DACs, head impedance, mic. Now, power, intermodulation, distortion. I always find this be pretty interesting. You can do this test different ways, and let's just go ahead and do it. Alright, same thing, minus 27.7, same setup. Okay, let's go ahead and run it. I'll move this out of the way. Oh, look at that. That's really cool. See the 2 whoa, that was fast. You see the 2 frequencies that were next to each other? That's what the intermodulation distortion test is all about. Alright guys, turned off this so I could just talk to you without worrying about what's going on. The intermodulation distortion test, that's an interesting test. It can be done different ways. This one has, if you stop the screen, you can look at the 2 frequencies that it's injecting side by side. What happens generally when you do something like that is those 2 frequencies have harmonics, right? And if those harmonics land on top of each other, they can beat on each other. But what will also happen is one of them will end up kind of having what they call sidebands. It's kind of like when you put a 1 kilohertz tone in. Well, you know, if we look at our switching frequency for the Class D, you see that fuzz, that 450 kilohertz switching on top of our 1 kilohertz or 10 whatever whatever frequency you put in. You see that right on top. It's kind of what's happening when you put 2 frequencies in there. They kind of right on top of each other, and so what you see in the frequency domain is you see the 2 spikes and the 2 frequencies you put in, but that adding and subtracting of each other, that's what essentially happens. That's what happens. So you'll see, let's say if you had a 10 kilohertz and 1 kilohertz, at the 10 kilohertz spike, you'd see 9 kilohertz and 11 kilohertz spikes next to it, and at 1 so you'd see stuff like that. So what happens is those amplitudes, if they're beating on each other and they add to be too high, then you could hear that. That's distortion, harmonic distortion caused by other frequencies on top. Now you can understand that if you're playing music with lots of different notes, you can just imagine what would happen. So you don't want that to occur. The 2 they put in there, I'd have to go back and look at that, but I think it was the 19 and 20 kilohertz test. There's also one where they put, like, I think it's 60 hertz and 7 kilohertz, and in that case they're different proportions. I have to look again, but one of them is like, anyway, I think the 60 hertz is a quarter of the level of the 7 kilohertz, or maybe it's vice versa, and it's probably not a quarter, it's probably a third or something like that. Anyway, they're proportionate. There's certain proportions that you do for that test. So there's different ways you can do an intermodulation distortion test, which I think is a great test. Personally, I think that's a great one. Unless you never see any problem. If you never see any problem, then, well, maybe amplifiers just don't have a problem with that. But if they do, and that's one thing I want to test for, because I want to see if they do show something different from amplifier to amplifier. Okay, so let's just look at the results and see what this one looked like, and then as we start looking at other amplifiers, we'll know more about how well this one did. Alright, so here's the power. It did it at 1 watt, which is awesome. It did it at 3 different power levels. So it did a 1 watt, 10 watt, and 110 watts, which is kind of funny. Sometimes this line's not quite 110 watts, so I don't know what's going on there. But anyway, I just noticed that sometimes it's over there, sometimes it's not. But it could be the resolution of the test and how it takes the test. I don't know. But alright, anyways, over on the left is intermodulation distortion decibels, and over on the right it's in percentage. So, you know, if we look over here, it's minus 90 dB. Minus 90 dB, if you haven't you know, figured out what I'm going to say. Minus 70, minus 90, that's all super small stuff. And the one thing to know, as far as characterizing the amplifier, it does increase from 1 to 10. But from 10 to 100, if anything, it decreases a little bit. So, not very much, but it does a little bit. The interesting thing is it doesn't continue to rise. So, that's curious, right? Let's go on to the next test. Alright, so we came down here and we did the IMD, output impedance. Okay, output impedance, this is cool. Same thing, minus 7. Oh, I can select the amplitude that I want to do this. I've actually done this test before, and I think we need to do it at the 10 watt. Because, guys, when I do this at the 110 watt, I think the way it goes from 0 to 110 watts, this guy goes in protect mode. I'm not sure what the QA401 is doing to take this measurement, but it's an interesting test. It's going to scan across the frequencies at, let's say if I start off at 4 ohms where I'm set up now. So it's going to do it at 2 different resistances. So I'm set up 4 ohms right now. I can say start at 4 ohms and then go to 8 ohms, which is what I'll do. So it'll do that, and then it'll do the 4 ohm, it'll scan across, and then it'll do, so it's going across frequency. I can tell it's doing that, but I don't, I'm not sure. I don't know if it's just taking the current measurement and voltage and then dividing that to get the resistance, which is what I'm assuming. But then what it does, I think, to get 2 different measurements to make sure that it's internal impedance versus something happening at the load, then it's going to give me a chance to put the 8 ohm resistor in, then it'll repeat. Okay, so it's kind of a cool test. So I'm just gonna I think I'm just gonna pull up the result instead of showing. I'll start it and then I'm gonna pull up the result because it does take a while. Alright, so load impedance first pass is 8. I didn't reverse last time, so I've done this test before. I did all these tests just to make sure that things worked out, okay? Because I wanted to make sure that 110 watts worked before I did a whole bunch of tests. So, okay. Anyway, so let's go ahead and start to run it. So see, it says first pass. Make sure you got the 4 ohm, and then you do it. And then it sits there, and it does all this stuff. And it takes a while to run through these tests. The other thing to note, whenever you're seeing these tests, if you notice, it starts off low frequency, noise floors up here. And look at all these harmonics. And then it drops. But anyway, it's going to take a while to do this test, and then it'll come back and say, change to 8 ohm. I have to stop it, put the 8 ohm in, and then continue. So let's go see the results. Alright guys, so here is the graph. Okay, I can make that a little bit bigger. Alright, so I've named all these, and if you notice I've been putting LED power supply. That's this power supply I'm using, the 600 watt. I think I want to redo this test using just a bench DC power supply just to see. Maybe it's unfair to use a power supply that I bought to put on this. Maybe I should use another power supply just to compare the measurements. So I'm not going to do that in this video, but that's why I did this. Okay, if you guys are interested in me doing that, I'll show it to you. Otherwise, I don't know, maybe I'll just do it real quick just to see if I see anything different. But alright, so this is what we're looking at. This is 0.1 ohm right here, so we're actually below that. So very small impedance. And then this is interesting though, guys. About 1 kilohertz where the amplifier starts to roll off, as it rolls off, the impedance goes up. Interesting, right? So it goes up to over 1 ohm. Here's 1 ohm right here, and there's 20K. It's gone up to it's about 1.3, right? Something like that. So yeah, I mean, gone from 0.1 to 1.3. So this stuff over here, if you, let's say you had a I'm testing this with 4 ohms. You know, let's say you had a 4 ohm speaker, right? And you had a tweeter that was 4 ohms, but this guy, he's going to compete with that, right? He's over an ohm. So I think that impedance curve is interesting. I want to do more amplifiers to see how they test out, because that looks weird to me. So hey guys, by the way, I did a bunch of these tests with the Ice Power 125. What was that? ASX2. And then I gave it to a friend. I'm going to get it back. I wanted to redo all those tests to make sure I had a nice clean setup and all that. But if you guys want, it might be another week before I get that amplifier back. I can post those graphs. That way you have something to compare to this guy. But I'd have to go back and pull those up. But from what I remember, the impedance looked a lot more impressive. Something what I would expect. Being a power supply guy, I just understand how when you match two systems together, like a power amplifier to a speaker, a preamp to a power amp, or an EMI filter to a power supply, or a power supply to a power amp, whenever you're connecting these things, you want where the signal comes from, the source, you want to be very low impedance to the thing you're powering, because you don't want to take any of that power away. So let's say in this case, you had a tweeter, and let's say at 20 kilohertz, or even at 10 kilohertz, it's up to 0.7 ohms. So let's just say that you have a 4 ohm tweeter, and now you've got 4.7 ohms. So whatever signal you're trying to send out to your tweeter, there's that percentage of it, 0.7, which is almost 20% of the signal is being lost on your output impedance of your amplifier. So maybe this is just indicative to an early roll-off, or maybe it's something else. Maybe, I don't know. I'm just curious. I'm also curious on those output inductors. Are they the proper size? I don't know. I'm curious about that. I'm wondering if we're losing too much signal on those. There's the snubber on the output. Now, that weird deflection, I need to put the 8 ohm and run that test to see, maybe this amplifier is set up for 8 ohms and we won't see that resonant peaking at, what was it, 50K or whatever it was. Maybe we won't see that with 8 ohms. So, that's interesting. I was only going to do the 4 ohms on this test because I thought I was going to choose the harder resistance, and I thought, hey, if everything looks good at 4, they should just look better at 8. But now it seems kind of ridiculous just to assume that. I should test it, right? So maybe if you guys want, I'll show that in another video too. Give me comments down below what of these ideas I've talked about you'd like to see. Yeah, sorry, got those allergies, kind of suffering a little bit from that. But yeah, I was putting off this video just hoping that my allergies would clear up a little bit. But all right, guys, it's getting late. It's I gotta go to work in the morning, not too far off, so I gotta wrap this up. But I appreciate you guys for watching, and I want to thank Alan Hurst 1579 for his super thanks. I really appreciate that, Alan. That's super awesome of you. And I want to give 2 thumbs up to my patrons as well. Appreciate all that. Yeah, that Patreon growth has been a really slow growth, but hey, I'm just so appreciative that I got Patreons. I think that's super cool, and people hitting that super thanks that YouTube added. Man, I'm glad they added that, because I've had people here and there. Last video I had 3 people. That was crazy. But yeah, usually a lot of times between videos I don't get any, but so I just think it's super cool when I get one. So Alan Hurst 1579, thanks so much. All right, guys, let me know what you think of these measurements. I'm going to do some more measurements to stack on top of what we've done. I was just trying to go through what we could on this. Guys, there's one more test that I forgot to do. Let's run over and do this test real quick. Hey, you guys stuck around, get a bonus test. Okay, let's do it. All right, guys, so here it is on the screen. Check it out. After output impedance, there's the THD versus output power. Now, I thought we did this, but I think we did. I think, like I said, some of these graphs are just the same thing taken a different way. So minus 27 to 7, increment 10, and okay, so this is done at a test frequency of 1000 hertz. So I could change that for different frequencies. And from what I saw before in other graphs, I could choose one of those frequencies put here. But I guess I'll just leave the 1000 for now. 4 ohm load. Okay, so it's 4 ohm load. That's cool. And let's go ahead and run it. Move this out of the way. Wow, that was a fast test. I always forget which ones are the fast ones. Okay, let me do some magic to this slide. Alright guys, this is what I've been doing to those other slides. I just put a title in here and alright, so I think that covers it. It's 4 ohms, 1 kilohertz, and it went from 110 or 11 watts to 100 watts and plotted that. So yeah, I think we've seen this with voltage down here instead of power. So I have to go back and look at those other graphs, but I think that's the main thing. You know what? Let's blow this guy up too. Let's go max value minus 40, min value minus 60. There we go. All right, so I changed it up. I added the 1 watt to 110 watts. So, all right. So I'm going to print these off and shuffle them around, I guess, and start comparing them to other amplifiers. So, yeah. Anyway, pretty interesting stuff. This is at 0.1. Yeah, close to 1. I mean, it looks very familiar, right? All right, guys. So, yeah. So I think that covered the testing. And we got, you know, some interesting results, right? And what do you guys think? Let me know what you think about all those results. And I was thinking about doing 8 ohms too. I think I'm going to do 8 ohms for my own library bank to compare against other amps. But if I find anything interesting, I'll publish it. But hate to do it twice. So anyway, let me know if you guys want to see that video. I'll do it kind of like this one. Maybe I'll do it faster and just do the 8 ohms real quick. The other thing is, you notice these slides, they said LED power supply. If I haven't mentioned that before, that's this one. I want to do it with one of the bench supplies, like one of these, like the Xantrex. That's a nice power supply, and that way I could take this guy out of the equation and see how it tests with, you know, something like that. So let me know what you think of that. Hey, I wanted to say 2 big thumbs up to Alan Hurst, 1579. He did super thanks. He bought me a cup of coffee or whatever. So I just want to say thanks so much. Appreciate that. That's that button YouTube added down below where you can do a super thanks. And yeah, really happy that some people have found that. You can also become a patron for those $1 a month. Appreciate all my patrons. You know, my list is pretty small, but really appreciate those guys. And appreciate all you guys watching the videos. A free way to support the channel is to give it the old like, share it, that kind of thing. Subscribe if you haven't done so. That'd be awesome. So, want to grow the channel, get more viewers and all that kind of stuff. So, yeah, God, I was looking around. I have another amplifier right here. I'm going to run through this test. That guy there is the talk of the town lately. So, I want to see how that stacks up to these. And also that ice power amplifier that I tested, I did take the measurements. I wanted to get it back and redo them all, make sure that I had a good setup. I think I did. But anyway, if you guys want to see that so you can compare it to this one, I'll publish those as well. So let me know what you guys think. Comments down below, please. That way I know which videos you want to see. And yeah, and by the way, I got to get back to my flyback power supply videos. And I got some other, God, I got so many videos. Man, I could do this full time easy, but I got to go work tomorrow. It's late. So, thanks for watching. We'll see you next time.